All right, this is a video on direct variation, and we will start with an introduction and then do a few solved examples. So direct variation is a special case of a linear function or of a linear relationship where the y-intercept is 0. Okay, so in this case, direct variation is we can use the form y equals k times x, and then we can also divide both sides by x and get y over x is equal to k. All right, so y equals k times x, or y over x is equal to k. K is referred to as the constant of variation. To make a connection with linear functions or linear equations, we have y equals mx plus b. B is the y-intercept. So if b is equal to 0, we would have an example of direct variation just using m instead of k. All right. Just to be clear, k in direct variation would be a number in the equation. K is a coefficient, represents a coefficient, and y and x would be variables. So as a quick example, say y equals 3 times x. We could also divide both sides by x to have y over x is equal to 3. So the constant of variation here is 3. Okay. We could maybe express this as a table as well. Pick some different values of x and y. Perhaps 2, 4, 6, 8. And then if x is those values, y would be 3 times those values, 6, 12, 18, 24. Okay, so we can express a table from a direct variation equation. We can also, by the way, consider or pretend, what if we were simply given our table and we wanted to see if this table represented an example of direct variation. So we can think about what y over x would be, and so we're checking the table to see if we have a constant of variation. 6 over 2, 12 over 4, 18 over 6, 24 over 8. Okay, and those all simplify down to 3, so 3 would be our constant of variation. We could even make a quick graph to model this, and let's say this is 2, 4, 6, and 8. And let's have this go up by 4s here. 4, 8, 12, 16, 20, 24. And so we could plot these points over 2 and up 6, over 4 and up 12, over 6 and up 18, and over 8 and up 24. Okay, and we could draw a line between them. Try to go through those points, and we could see that we have a straight line. It has a y-intercept of 0 and it has a slope of 3. Okay, so this slope here would be up 6 and over 2, so the slope would be 3. That's our k value, our constant of variation. But most important, I think, is that we have a y-intercept of 0. All right, so we can practice this a little bit with some examples and really just be thinking about what the constant of variation might be. So we can add another column to our table. What's y over x? We don't want it to be x over y. We want it to be y over x. 12 over 3, 32 over 8, 68 over 17. And I think I'm going to check the last one, but I think those all have a quotient of 4. So this first one would be an example of direct variation. It would be y equals 4x or y over x equals 4. Both of those would be valid ways of representing that. Okay, let's look at this next one. And once again, we can just try to find a variation and see if it's constant, a constant of variation. 15 over negative 3 is negative 5. Negative 42 divided by 8 is negative 5.25, and this is also negative 5. So these numbers vary, these quotients vary, so this is not direct variation. Okay, all those quotients, all those proportions would have to be the same for it to be an example of direct variation. You can also do a similar problem. Is it from equations? Is it an example of direct variation? Just looking at some equations. And so if we can create this form, y equals kx or y over x equals k, if we can get either one of those forms, then we do have an example of direct variation, where k is a number. So for this top one, looks like we can divide both sides by 5. And y equals negative 3/5 x. So k is negative 3/5. And this is an example of direct variation. Okay? Basically, we're isolating for y. We can do something similar here for this next one. Let's subtract 2 from both sides. And we get 6y equals 0.5x minus 2. Let's divide both sides by 6. And we get y equals, that's 1/12 x minus 1/3. And due to the fact that we have this additional y-intercept, this additional 1/3 that's being subtracted, that tells us that we are looking at a non-example of direct variation. This is not direct variation. Okay? If it was just the y equals 1/12 x, then it would be, but it's not. Okay? And our final example here, let's develop an equation. This is probably one of the more common ones you'll see. Let's assume y and x are varying directly, so they're varying in tandem. And when we know that y is negative 24, we know that x is equal to 6. So what's y when x is 3.5? So I like to start off these problems by first finding the equation, okay? And so let's do that in this yellow highlighted zone down here. We know that y equals kx, so therefore negative 24 equals k times 6. Okay, can we solve for k? Looks like k is going to be a negative 4. Okay, so we're still working on solving the equation. K is going to be a negative 4, dividing both sides by 6. And so y equals negative 4x. That's an example of our direct variation equation. Okay? Then we're going to answer the question that's being asked. What is y when x is 3.5? So let's do that over in here. Well, now we have an equation. We know that y equals negative 4x. So let's plug in our 3.5. So y equals negative 4 times 3.5. So y equals, I think that's 14, a negative 14. Okay? And that would be the solution to our problem, y equals negative 14. Nice, we got through it. That's a good place to stop.